So page 114, number 33, it says find f prime of a. And they give us the function f of x, or f of t, sorry, is 2t plus 1 over t plus 3. Okay? So we're looking for f prime of a. So that means what I'm going to be plugging in when I use the definition, the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so what I'm plugging in there for the a this time is just a, because they didn't give me a point. Okay, they just said a. So if they give you a point at which you're going to plug it in, then that x value is going to be your a. But if they don't give you a point, then you're just using that variable a. Okay. All right. So we just start plugging in. Then we go to the so f prime of a is the derivative of the function f at the point a. So we go to the function named f and we plug in a plus h. So everywhere that there's a t, because that's the variable that we're using here, everywhere that there's a t, we're going to plug in a plus h. Okay, so 2 times a plus h plus 1 all over, instead of t, we put in a plus h, and then plus 3. So that's the f of a plus h part. Now we're going to subtract f of a. So subtracting, instead of t, we're going to the function named f. Instead of t, we're plugging in a. So 2a plus 1 over a plus 3. And then that's all going to be over h. Okay, so the hardest part of this, once you get that set up, the hardest part is the algebra. Okay, the most common mistakes here are algebra. So you have to be super careful with your signs, and just remember your algebra rules. And don't forget that you're taking the limit as h approaches 0. That's what I always forget to do, is write that. Okay, so f prime of a then is equal to the limit as h approaches 0. Okay, so in the numerator, I'm subtracting two fractions. So what do I have to have in order to subtract two fractions? Common denominator. So how do I find a common denominator here? Multiply them together. So my common denominator is going to be a plus h plus 3 times a plus 3. Okay, so that's going to be the common denominator. So I'm going to have two fractions with that denominator. Okay, and that whole thing is going to be over h. All right, so in this first fraction, what did I have to multiply by in order to get the common denominator, a plus h plus 3 over a plus 3, or times a plus 3? I have to multiply by a plus 3. So I'm multiplying the numerator by a plus 3 and the denominator by a plus 3. Okay? So in the numerator, I'm going to go ahead and distribute this through. So that's going to give me 2a plus 2h plus 1, right? So 2a plus 2h plus 1 times a plus 3. So I had to multiply the numerator and denominator by the same thing in order to get that common denominator. What in the second term, 2a, so I have minus 2a plus 1 over a plus 3. What do I multiply the top and bottom of that fraction by to get the common denominator? Good. A plus h plus 3. A plus h plus 3. Okay, so in the numerator, I have 2a plus 1 times a plus h plus 3. Okay? All right. So we're just going to continue to simplify that. So if I subtract two fractions that have the same denominator, the answer is also going to have the same denominator, right? So I'm going to have a plus h plus 3 times a plus 3 is going to be the denominator. So now we just need to figure out what the numerator is going to be. So I'm going to go ahead and then that whole thing is going to be over h still. Okay, so in the numerator of this first term, I'm going to go ahead and distribute through. So 2a times a, 2a squared, 2a times 3, 6a, 2h times a plus 2ah, 2h times 3 plus 6h, sorry, 6h. And then 1 times a is going to give me a plus 3. Okay, then I'm going to subtract the answer that I get over here. So I'm going to put that whole thing in parentheses because we're going to have to distribute the negative through. So 2a squared plus 2ah. 2a times 3 is 6a. Then 1 times each term in the second parentheses, so plus a plus h plus 3. So f prime of a equals the limit as h approaches 0 of, in the numerator, 2a squared plus 6a plus 2ah plus 6h plus a plus 3 minus, so now I'm distributing this negative through to all of those. Okay, so negative 2a squared minus 2ah minus 6a minus h minus 3. Okay, all over the common denominator, a plus h plus 3 times a plus 3, all over h. Okay, so in the numerator, let's see what we can cancel out. All right, so we have 2a squared and a minus 2a squared, so that's gone. We have a 6a and a minus 6a, so that's gone. What else cancels? 2ah and minus 2ah. The a's and the 3's. Beautiful, isn't it? Don't you love math when it does that? Gets rid of all that stuff. So we're left with 6h over a plus h plus 3. Oh, there's a minus h. Sorry. We'll just put that on there. Times a plus 3. Yep, I missed it because it's so little over there. Sorry. You guys have better eyes than I do, and I'm the one who wrote it. Okay. And then all of that is over h. Okay. So I I have a fraction over h, and I'm going to make that h over 1. Okay? So that way I can flip and multiply. So f prime of x equals the limit as h approaches 0 of, that's 5h, over a plus h plus 3 times a plus 3. And then I'm flipping and multiplying that bottom fraction to get 1 over h. So the h's are going to divide out, leaving me with the limit as h approaches 0 of 5 over a plus h plus 3 times a plus 3. Okay, so now I can go ahead and apply the limit. So when I plug in 0 for h, I'm just going to get 5 over a plus 3 times a plus 3. So f prime of x, actually I changed these to x's and they should have been a's all the way. Okay, so f prime of a is equal to 5 over a plus 3 squared. Okay? And since we don't know what a is, we don't know what point we're finding the tangent, the slope of the tangent line for, we just leave it like that. So what this does is it gives me a formula so that if I want to find a tangent line, the slope of a tangent line anywhere along this function, I can just plug in the x value now, and it'll give me the slope of the line at that function. So,
would you cancel the h? 5 over a plus h plus 3 times the bottom one?
right here.
The bottom one?
This one?
No, the one under that. The one under that. Yeah.
Right here? Only after you plug in h is 0 there.
Okay.
Yeah. So I still wrote this limit as h approaches 0, and only after I apply it do I not write it anymore. Okay. Any questions?